Hi, in this video, we are discussing the ninth numerical from the exercise for the chapter Units and Measurement, which is the first chapter for 11th standard physics. So let's get started. Now, as for the question, we have an object, and this object is falling freely under the influence of gravitational force. Now, since it is falling under the influence of gravitational force, it will travel some distance, and this distance is denoted as small h. Also, since it is traveling this distance, the object will acquire some velocity, and this velocity is said to be denoted using the letter small v. Now, our velocity v depends upon two factors. First is the gravitational acceleration, which we denote using the letter small g, and second is the distance traveled by the object, which we already denoted as small h. Now, this dependency is given to us in the form of an equation where v is equal to k into under root of g into h. And we now have to perform a small dimensional analysis on this equation to prove whether this equation is dimensionally accurate or not. In the question, we have been also given that the term k in the equation is a constant term. With this, we have all the data to perform the dimensional analysis, and we have also decoded our question. So let's get started to solve the numerical and let's perform our dimensional analysis. First, we'll write the given expression on which we have to perform our dimensional analysis. So under the given section, we write our equation where we have v is equal to k into root of g into h. Now, before we perform the dimensional analysis on this particular expression, we need to know the dimensions of some quantities participating in this expression. So we need to know the dimensions of velocity, we need to know the dimensions of g, that is acceleration due to gravity, and we need to know the dimension of distance h traveled by the object. So first, we'll calculate the dimensions of all these quantities. So let us build a small table. हम फर्स्ट कॉलम में हमारे क्वांटिटीज को मेंशन करेंगे. सो टेबल के अंदर जो भी क्वांटिटीज है वो रहेंगे. सेकेंड कॉलम विल बी डिनोटेड टू द फॉर्मूला. अगर कोई क्वांटिटी फंडामेंटल क्वांटिटी नहीं है तो उसको हम फंडामेंटल क्वांटिटी में एक्सप्रेस करेंगे यूजिंग फॉर्मूला. एंड इन द थर्ड एंड द लास्ट कॉलम हम मेंशन करेंगे हमारे डिजायर्ड क्वांटिटीज के डायमेंशंस. ठीक है, तो सबसे पहले लेट्स स्टार्ट बाय हाईलाइटिंग आवर थ्री कॉलम्स. And let's start with the first quantity जिसका dimensions हमें ढूंढना है. So the first quantity is the velocity जिसको हम represent करते हैं using the letter small v. Now, as per the definition, velocity is said rate of change of distance. So formula is distance upon time. Now, in this formula, both the distance as well as the time are fundamental quantities. So what we can do is we can directly calculate dimensions for velocity at this point. So if we were to calculate the dimensions of velocity, it would be the dimensions of its expression. So that is dimension of distance, that is L in the numerator, and dimension of time, that is T in the denominator, which gives us the dimensions for velocity, that is L to the power 1 and T to the power minus 1. So these are the dimensions for our quantity velocity. Moving on to our next physical quantity, that is acceleration due to gravity. So acceleration due to gravity. And we denote this acceleration due to gravity using the special term, that is small g. Now, by definition, acceleration is velocity upon time. But although time is a fundamental quantity, velocity is not. So we need to express velocity in fundamental quantities as well. So by definition, velocity is distance upon time. So distance upon time. So acceleration will be distance upon time upon time. And if I were to express this in a more clearer way, I get the next formula or the alternative formula for expressing acceleration, that is distance upon time ka square. So this is an alternate way to express acceleration as well. And from this, since distance is a fundamental quantity, time is also a fundamental quantity, we can now express the dimension for our acceleration due to gravity. So dimensions of acceleration due to gravity is the dimension of this expression. So that is distance, that is length का dimension in the numerator and time का dimension raised to 2 in the denominator. इससे हमें मिलता है acceleration का dimension as L to the power 1 and T to the power minus 2. इसी के साथ अब हमारा बस टास्क बचा है टू कैलकुलेट द डायमेंशंस ऑफ आवर डिस्टेंस represented by the letter small h in this particular instance, and this is very easy because distance is simply distance and it is a fundamental quantity. So हम h के dimensions directly distance के dimension से match कर सकते हैं, that is L raised to the power 1. And now we have the dimensions of all the quantities participating in our given expression. Now that we have the dimensions of all the required quantity, we still have k left. What do we do about k? So as per the question, k is a constant. So because of this information, that since I can write since k is a constant, we can assume k to be dimensionless. So we assume the term k as dimensionless, and it won't be participating in our dimension analysis whatsoever. ठीक है? So now that we have said that k is a dimensionless constant, now let's get to our dimensional analysis. So dimensional analysis of the expression, v is equal to k into root of g into h. So from this expression, if I were to calculate the dimensions of LHS, let us calculate the dimensions of LHS. So सबसे पहले we are calculating the dimensions of LHS, because dimensional analysis का point यही होता है कि all the quantities, that is quantity on the LHS and the terms on the RHS, should have same dimensions. Only then we can say that our given equation is dimensionally correct. If the quantities does not equate in dimension, it's not dimensionally correct. So we will calculate the dimensions of LHS separately, and then we'll calculate the dimensions of RHS separately. And if these two dimensions match, we can say that our expression or equation is dimensionally correct. So अब हम सबसे पहले calculate कर रहे हैं dimensions of LHS. So LHS में dimensions would be equal to the dimensions of velocity, since LHS में that is the only term, that is velocity. And हमने अभी calculate किया था velocity का dimensions, which was L to the power 1 and T to the power minus 1. तो अगर हम देखेंगे, so dimensions of velocity is L to the power 1, T to the power minus 1. Let us quickly calculate the dimensions of the right hand side of our equation. So basically dimensions of R dot H dot S. And in this case, the dimensions on the RHS is due to the values under root of G into H. So in quantities का जो dimensions होगा, वही हमारे RHS का dimensions भी होगा. So this can be represented as dimension of G H to the power 1/2, which can be simplified as dimensions of G to the power 1/2 and then dimensions of H to the power 1/2. Now we know the dimensions of G and H as we have already calculated. So let us substitute those dimensions. So in place of G, I can substitute it as L to the power 1, T to the power minus 2 raised to half, into the dimensions of H, which was L to the power 1 raised to the half. If I were to use the laws of indices, I would get the resultant dimension as L to the power 1/2 and T to the power minus 1 into L to the power 1/2. And again, if I were to use the laws of indices, L to the power 1/2 into L to the power 1/2 is L to the power 1/2 plus 1/2. That gives us L to the power 1 and T to the power minus 1, which is the dimensions of our RHS. So हमारे RHS का जो dimension है, that has come out to be L to the power 1 and T to the power minus 1. So let me just mark this by equation 2, and let me mark the equation dimensions of LHS by equation 1. So now if I were to make a statement that from equations 1 and 2, we can state that the dimensions of LHS, that is left hand side of our equation, is equal to the dimensions of R dot H dot S, that is the right hand side of equation. Because as you can see, हमारे LHS का dimension is also L to the power 1 T to the power minus 1, and हमारे right hand side का equation का dimensions are also L to the power 1 and T to the power minus 1. And since हमारे जो है expression के LHS और RHS के dimensions equal आए, we can say that hence we can say the expression V is equal to K into under root of G into H is a dimensionally valid equation. So हमारा जो dimensional analysis है, that has been proved. So it is dimensionally valid equation. And with this, we are done with the question. If you want the PDF of this solution, make sure you check out the description box. I hope this helped you. Thank you.